Hello and welcome to this biopsychology topic video, this one looking at ways of studying the brain, the essay writing and the evaluation. This video is one of three, and in part one we outlined and evaluated the four ways of studying the brain. In the second part we looked at how to answer different types of exam questions, and in this final video we'll look at how to structure and write an essay on this particular topic. Let's imagine you've got the following essay question: discuss ways of studying the brain for 16 marks. A possible structure might look like this. So you might outline fMRI and EEG. I recommend only outlining two different ways of studying the brain because there is a danger if you do three or four that the quality and depth of your answer will be reduced. Then you might evaluate in terms of temporal resolution, where you say fMRI has better temporal resolution than EEG. You might evaluate in terms of spatial resolution, where this time round you'll say that fMRI has better spatial resolution than EEG. And then finally, you might talk about causation and the fact that fMRI and EEG do not show causation particularly well. If you've got time, you might have time to embed some issues and debates, and the idea of biological reductionism and experimental reductionism work really nicely here. So let's start by looking at an outline, and remember the aim is to provide a clear, concise, well-detailed and accurate outline that's approximately 150 to 175 words long. So here's one I wrote earlier. I said fMRI is a brain scanning technique that measures blood flow in the brain when a person performs a task. fMRI works on the idea that neurons in the brain which are the most active use the most energy in the form of oxygen and glucose. Deoxygenated and oxygenated hemoglobin have different magnetic qualities, and an fMRI scanner can detect these different magnetic qualities and can be used to create a moving 3D map of the brain. That first part is 80 words long, so provides a nice, clear, well-detailed outline of fMRI. The answer then goes on to say an EEG, so an electroencephalogram, measures electrical activity through electrodes attached to the scalp. EEG scanners work on the idea that information is processed in the brain as electrical activity in the form of action potential or nerve impulses. Small electrical charges are detected by the electrodes that are graphed over a period of time, indicating the level of activity in the brain. EEG can be used to detect illnesses like epilepsy and to diagnose other disorders that affect the brain, like Alzheimer's disease. There we have it. It's about 160 words long, that particular outline. We've done our two different ways of studying the brain. They're clear, well detailed and accurate, and really within our word limit, which is what we're aiming for. Now let's look at how we might evaluate using the idea of temporal resolution, which will incorporate here both fMRI and EEG. So this is a really effective way to evaluate both treatments or both ways of studying the brain at the same time. So you might use the double whopper technique here, where you provide your point, you bring in your first bit of meat, your evidence, you then provide a counter argument, which in this case is going to be us comparing the two different ways of studying the brain, and then you bring in an explanation. So you might say an advantage of EEG in comparison to fMRI is that it has good temporal resolution. Temporal resolution refers to the accuracy of a scanner in relation to time, or how quickly the scanner can detect changes in brain activity. EEG scanners take readings every millisecond, meaning it can record the brain's activity in real time as opposed to looking at the passive brain. We're then going to provide our counter argument here and bring in the idea of fMRI. However, fMRI scans have a temporal resolution of 1 to 4 seconds, which is worse than other techniques, in this case EEG. This suggests that EEG can provide a high degree of accuracy when examining the onset of brain activity, allowing psychologists to make accurate conclusions in relation to the timing of neural activity in comparison to fMRI. So there we have it, a really nice effective evaluation paragraph that's incorporated both scanning techniques, which makes this really sort of packed out. Let's do exactly the same now for spatial resolution, but flip it the other way around. This is going to be a strength for fMRI and a weakness for EEG. So here you might say, however, a strength of fMRI in comparison to EEG is that it has good spatial resolution. Spatial resolution refers to the smallest feature that a scanner can detect and is an important feature of brain scanning techniques. Greater spatial resolution allows psychologists to discriminate between different brain regions with greater accuracy. fMRI scanners have a spatial resolution of approximately 1 to 2 millimeters, which is significantly greater than other techniques, in this case EEG. EEG, on the other hand, can only detect activity in superficial regions of the brain, that's the surface regions of the brain. Therefore, psychologists can determine the activity of different brain regions with greater accuracy when using an fMRI scanner in comparison to when using EEG, which makes fMRI an ideal choice when trying to pinpoint specific brain regions. And we could, if we wanted to sharp here, link that to the idea of localization of function. Okay. Last but not least, let's see how we can talk about the idea of causation here. So here we might say an issue with both fMRI and EEG is the inability to show causation. fMRI scans do not provide a direct measure of neural activity. fMRI scans simply measure changes in blood flow, and therefore it's impossible to infer causation at a neural level. And likewise, so it's actually two limitations here. The issue of EEG is that the electrical activity is often detected in several brain regions simultaneously. Therefore, psychologists are unable to conclude whether particular brain regions are associated with particular functions, in the case of fMRI, and which area of the brain the electrical activity took place in the case of EEG, making solid cause and effect conclusions impossible for both ways of studying the brain. So there we have it. I've just placed that essay on screen now, the entire essay, and it fits one page type, that size 12 font, just over 500 words long, with 161 for our outline and 3 double whopper evaluation paragraphs incorporating both fMRI and EEG, 344 words, and that will be provided in your MyTutor2 account along with the other resources from this webinar. So you can see the sort of nice structure we've got there of all of our outline first. 3 simple but clear and effective evaluation paragraphs should be enough to get us into that Mark Band 4 territory. There you have it. This was the final video where we looked at the structure of how to write an essay for the ways of studying the brain. Really hope you found this and the other 2 videos in the series useful. Thank you for watching once again. Goodbye for now.